So by the end of today, you're going to be able to find all the rational and the real zeros. So real zeros include rational zeros, but they also are going to include irrational zeros. Okay, so we're going to talk about how they relate to the graph. Okay, so 3.4 is called real zeros of polynomials. Now there is a theorem called the rational zeros theorem, and this lets you know what all of the possible zeros are. It's important to know that these are the possible zeros and not the actual zeros, but they can be helpful if you have some that are not integers. So every rational zero of p of x, so some polynomial, is of the form p over q. Okay, every rational zero of p of x is of this form p over q, where p is a factor of the constant term Okay, so that would be a factor of the number, the very last term. Okay, and then your Q value is going to be a factor of the leading coefficient. Okay, so P is a factor of the constant term. Q is a factor of the leading coefficient. Okay, so this P over Q can help you generate all of the possible values. So I want you to pay special attention to the directions. In example 1, it says, find all the possible rational roots. Okay, that keyword there being possible, that's going to be a little bit different. If you look at example 2, you're going to be finding the rational zeros there, and it doesn't say possible, so it is a little bit different there. All right, so then when you are finding these, you're going to do P over Q. Okay, P is going to be the factors of, what's our constant term here? 12, great. Okay, and then Q is going to be the factors of, what's our leading coefficient? 2. And then I'm going to help you write these out because this is a little bit different at first. So when you're writing the factors of 12, you can write them in order. The first factor is always going to be 1. Okay, so 1 goes into 12, and it can be positive or negative, so we write plus or minus. Okay, 2 goes in there, 3, 4, 6, and 12. Okay, and I think I got them all. 3 times 4, 2 times 6, 1 times 12. That's going to be over the factors of 2, which is only plus or minus 1 and plus or minus 2. And then what we're going to do to find the possibilities is divide. All right, so when you divide, if you divide 1 by 1, you get still plus or minus 1. Okay, that's going to happen for every single one of these. 2 divided by 1, 3 divided by 1, 4 divided by 1, 6 divided by 1, 12 divided by 1. Okay, now we're going to divide everything by 2, and if it is already listed, you don't have to list it again. All right, so 1 divided by 2 is 1/2. That's not on our list, so we're going to add plus or minus 1/2. All right, 2 divided by 2 is 1. We already have that. 3 divided by 2, we're going to add it. 4 divided by 2 is 2. 6 divided by 2 is 3. 12 divided by 2 is 6. So these are our answers. Okay, that's how you generate those possible zeros. Okay, so if that polynomial has rational roots, it would be on this list, okay? If it just says to find the possible ones, you do not have to find the actual ones. That is what we are going to do in example 2. So here it says find the rational zeros. Notice it still says rational, okay? So some of the directions are going to seem similar. And then we're going to write the polynomial in factored form. If you can write the polynomial in factored form, that means it's factorable. Okay, you're going to be able to find that pretty quickly. But this process I'm going to show you today is something that we're going to use over and over for multiple sections. Okay, so I'm going to practice that process with you. So the first thing we're going to do is we're going to find the x-intercepts on the graph, or P of x. So let's go ahead and plug P of x into our graphing calculator, or if you don't have yours with you today, you can plug that into Jetmos. Okay, and then we're finding the x-intercepts. When you guys did your preview packet last week, you might remember that there were a couple questions where you had to say what the real zeros are. Okay, and the real zeros are your x-intercepts. Okay, now the x-intercepts that you're going to find here, if you were to list out the possible rational roots, they would be in that list. In fact, if you look at the way your book tells you to do it, they tell you to generate those. And I actually took that out this year because we're just going to find them on the graph, okay? All right, so when you graph, you might say, oh yeah, that's definitely -1, this is 5, this is 7. If you wanted to check on your table, what can you look for in the table? How do I know what my zeros are looking at the table? Yeah, your y is 0. Okay, so we can just verify it with our table. So I see -1. Okay, and then 5 and 7. Yep, those are indeed your x-intercepts. Okay, so when you're doing a problem like this on your homework, if you have 3 x-intercepts, okay, those are all of your roots, because remember, your roots should match the what? Yep. Okay, so the number of zeros is equal to your degree. Okay, so when you're doing this on your homework, if you wanted to write these down as your rational zeros, -1, 5, and 7, and then write it in factor form, you can. Okay, those are going to be your zeros here. I'm also going to show you the process that we're going to be using for the rest of today to get you more comfortable with that. And it is something that you might remember from last year. So we're going to verify zeros using synthetic division. The goal with verifying with synthetic division is that you keep using it until you have a quadratic equation, and then you solve the quadratic equation. Sometimes you'll be able to factor, like in all of these, because it says you're going to write it in factored form. And then if you can't factor, then you can use the quadratic formula, which we'll also use today. Okay, so if you're verifying with synthetic division, you can pick which one of your zeros you want to use here. Okay, so I'm going to line up my coefficients, 1, -11, 23, 35. Do you guys have a preference on which zero you want to use? 5, okay, I was going to say, you can use any one of them. So drop down the 1 times 5, add them together, -30, -7. Okay, if your remainder is 0, then this is an x-intercept. Okay, so we know that that is one of our answers. Okay, then this is a quadratic. How do we know that? Well, we've been working with synthetic division, so we know this is our number, this is our x, this is our x squared, and if this is factorable, if it says to write it in factored form, this polynomial is going to be factorable. Okay, so we can split these up, x and x, and we used 5, right? So guess what? This should be these in factored form. You get -7 as a product. You want a -7 and a +1. -7 plus 1 is -6. A negative times a positive is a negative. And then you would just set each one of these equal to 0 and solve. Okay, so your zeros would be 7, -1, and 5. So this is a 0 as well. Okay, again, for this one, they're all real zeros, right? So if they're real, they're going to be your x-intercepts. Okay, you found them all already. That's why I said when you're doing this on your homework, it is perfectly fine if you find your x-intercepts and then you write them in factored form. So you can also use this factored form here. So you have x minus 7 times x plus 1. And then how would we write 5 as a factor? X minus 5. Okay, so those are going to be your two answers. Okay, and then in step 3, it says identify zeros and write in factored form. We just did that. Okay, and it says factors must be of the form. In this case, your factor, it can have a coefficient. It doesn't have to be 1. They just have to be integers. Okay, so, oops, I want to say minus c, not plus c. You missed your pen today. Okay, and then A and C are both going to be integers. All right, let's try the next one. Okay, so I want you to go ahead and do those first 2 steps. So let's find the x-intercept. Let's go ahead and graph it. Okay, do we need any more time to find the x-intercepts? All right, so what were your x-intercepts here? Yep. And it doesn't matter which one you choose to do the synthetic division. You can do 3 or you can do -1. Whatever you get, you're going to end up factoring it anyway. Okay, but did you guys see any other times where it crossed the x-axis? Let's look back at our graph. Yeah, so you have a number there that's not going to be an integer, right? And this one, it is kind of hard to see, like, is it touching back or does it go through it twice? Okay, so with your x-intercept, here you have 2 of them that you can see right away. If you check with your table, okay, if it's not an integer, you aren't able to see that with your current setup. Okay, so that's why it's going to be useful to use your synthetic division at this point. So again, I just want to stress in that first example, you didn't necessarily have to use synthetic division because you had all of the zeros. So because this is 3, there should be 3 zeros. How many do we already know? 2. We already know 3 and -1. So if we want to write those as part of our answer, we can absolutely do that. And then let's set up our synthetic division. Remember to check for placeholders if you need them. And what do you guys want to do? You guys want to do 3 or -1? All right. It's not that you don't know, because you'll be able to find it. It's just that if you're looking at your integers and not using your 0 feature, then it's not something you'd see right away. Yeah. And you could also adjust your table to find that as well. All right, we'll use -1. Okay, so 3 times -1 is -3. So -7, -6. Okay, if you can see this on the graph, it's a 0, and you do not get a 0 here, then something went wrong. Because if it is an x-intercept, your remainder should be 0. And again, we have a quadratic. So you have 3x squared minus 7x minus 6 is equal to 0 there. So then we're going to factor. So you have 3x and x. You have to start it like that, right? 3 is a prime number. And then if you're trying to figure out what multiplies to -6 but adds to -7, you can do your guessing and checking. Keep in mind, we already found that this is -1. So one of our factors is going to have to produce the answer of 3. And I already know if 3 is an answer, one of my factors has to be x minus 3. So I might plug that in, right? And then 3 times 2, you could use that to help you. So this would be 9, -9 plus 2 to get -7. And then we could set each one equal to 0. Okay, so we already have the 3 written down. We already have the -1 written down. So now that -2/3 is going to be the last one. Okay, and then when you're writing them in factored form, again, I think this is helpful. So you cannot write it with a fraction. So you can't write x plus 2/3. You have to write it like this. 3x plus 2, because they have to be integer coefficients. And then if it's -1, it'll be x plus 1. Okay, so the synthetic division in ones like this is helpful because you can factor, you can see the integer coefficients, and you don't have to search for anything that is not an integer. Other questions for me on example? Let's say example 2. Should be example 3. Any questions for me on this example 2? All right. then let's change this. Example 3. Okay, so here it says find all the real zeros. We're going to use the same steps. Oh, just kidding. So, but it shouldn't say example 1, it should say example 2 now. I may have added another example. Didn't change that. So when you're finding all of the real zeros, that includes irrational as well as rational zeros. Okay, so you're going to have values that you are not going to be able to determine just by looking at your graph. And that's because we are going to be writing the irrational zeros in simplest radical form. Okay, so irrational zeros, if they're real, which they will be here, they will be on your graph, but they will be decimals. Okay, and so sometimes we're going to have to use the quadratic formula. Other times you might be able to factor them. So when you're finding all the real zeros, there are so many different types. So I wanted to show you a couple of different ones for this. So the first thing we're going to do for A is graph it. Okay, you can always start with your graph. Okay, and on your graph, you can see your 4 zeros. These are your x-intercepts. Okay, so for your x-intercepts, you can see they're at -2, -1, 1, and 2. We know because it is degree 4 that there are 4 zeros here. Okay, so when that happens, you can write those down as your zeros. Okay, sometimes you might not recognize that right away. You can still check it with synthetic division. In fact, a couple of cool things happen with this that I want to show you. So when you check it with synthetic division, this would be one where you have to put in your placeholders. So you have 1x to the 4th, you have 0x cubed, you have -5x squared, you have 0 for x, and then 4. So just be careful of that. And then you can pick any of these to plug in and check. I chose the positive. Okay, so we can practice your synthetic division by plugging in 1. Okay, yay, we get 0. Okay, this is why I wanted to show you the synthetic division on this, because all the ones we've done so far, we got a quadratic right away. Okay, but with this one, what do you get? What type of function is this? Cubic, because this is your number x squared, x to the 3rd. Okay, so if it's a cubic function, you have a couple of options here. Okay, what I recommend is that you choose a new x-intercept. And use the coefficients of the cubic function. Can't do it. Okay, so then you're going to use 1, 1, -4, -4. Okay, and I chose to keep with the positives because I thought they would be easier to do the synthetic division. So 1 times 2 is 2, add straight down, 6, 2, 4, yay. Okay, and now that I have a quadratic, if you can factor, factor, but that's not going to happen every single time. Okay, so I know if I'm trying to factor, if it multiplies to a positive and adds to a positive, they're both positive. Does not matter what order you do them in, but you should have 2 and 1, which will be -2 and -1 for your zeros. Okay, and again, this one is special. So your zeros are positive and -1, and I'm fine if you put plus or -1 and plus or -2. Okay, and you should have a total of 4 zeros. Okay, now something else you could do, and I'm just going to show you one more method for this because there are a couple of other ones, which is why I wanted to show you this one. Okay, or if you can factor this right away, x to the 4th minus 5x squared plus 4 equals 0, okay, you can do that. What times what is going to be x to the 4th? X squared and x squared. Multiplies to 4, adds to -5. And then do you notice that these are the difference of 2 squares? Again, this does not always happen. This is special. Okay, and again, you would get the same zeros. Okay, so there's going to be lots of different types of these. The most important thing is that you practice, so I'm going to give you time to do that today. And then when you get a cubic function, there are cases where you can factor the cubic function. This happens to be one of those cases. You don't have to write this down. I just want to show you. If you are factoring a cubic function, there's 4 terms. So what method do you have to use to factor? Grouping, yes. Okay, so then when you take this out, x squared, this would be x plus 1, -4, x plus 1, and then you'd be able to break that down even further. Okay, so that polynomial just had a lot of cool things, so I wanted you to see one that was a little bit different. Okay, let's try part B. Okay, part B is going to be a little different as well. And if you want, you can always identify right away what your degree is. So if your degree is 5, you know you need 5 zeros total. Okay, right now we're only working with real zeros, which is nice because real zeros you can always see on the graph. It's just if they're irrational, we are going to be writing them in radical form. And so we're going to have to use some of these methods that I've been showing you in order to find those. Okay, which is why I wanted you guys to see the synthetic division multiple times, even though it was not necessary for every single one of those, okay? Okay, so I'm going to give you a moment now to write down your x-intercepts, and then I want you to do one of the synthetic divisions. once you get to your graph, your first step is to write down those x-intercepts. Again, if you're having trouble identifying them just from this alone, please use your table function so you can see them. So you have -1 and 2 in terms of your whole numbers, right? In terms of the integers. Any other whole numbers? All right, then let's go to step 2. So we have 1, -4, -1, 10, 2, -4. Okay, so I'm going to use -1 first. It's okay if you didn't. The order that you use them in does not matter. And then, yay, we get a 0. Okay, now here, this is a number x squared, x cubed, x to the 4th. This is a quartic. So we have to keep going. When you know that that's not a quadratic, if you want to hook on the next synthetic to this, you can absolutely do that. Okay, so then we get 2. We're going to pull that down. 1 times 2, -3, -6, -2. Okay, yay. And then here I have a cubic function. So last time we were able to factor it. Let's see if we can factor this. We can do it together on mine. So x cubed minus 3x squared minus 2x plus 2. So if I factor by grouping, I can take out x squared. Here I can take out -2. Okay, can I factor that by grouping? No, because these have to match, right? Okay, so I have to keep going until I get a quadratic. Okay, there is something special about this graph that we're going to talk about. So, in Algebra 2, you guys learned about something called multiplicity, which is where a 0 happens more than once. Do you guys remember what situation that happens in, what the graph looks like? Okay, so when you are looking for a multiplicity, you have a multiplicity if it touches the axis and doesn't go through it and it comes back. Okay, so do you see this maximum value here? The maximum lays on the x-axis. When that happens, there's a multiplicity. That kind of ring a bell. The touchback, I believe is what we called it. It touches it, it doesn't go through, it comes back. Okay, so there's an even multiplicity here at -1. Okay, so this has a multiplicity. Okay, and that is because the local max is on the x-axis. And if you want to draw like a little sketch to show that's what it is. That's at -1. Okay, so if the maximum is on the x-axis, there's going to be a multiplicity. So what that means is you can use -1 again. The zeros won't work twice unless it's a multiplicity. If I did 2 here, it wouldn't work. I wouldn't get 0. Okay, so 1 times -1 is -1. This would be -4, 2, -2. Yay, now I have my quadratic. Okay, so for ones like this, you have got to show the synthetic division and you've got to show the quadratic formula, which is what we're going to do next. Okay, so this is your number, this is your x, this is your x squared. Okay, so we have 1x squared minus 4x plus 2 equals 0. if I tried to factor that, because that is a 2, right? The only thing I can make it is -2 and -1. Does that add to -4? No. Okay, so this is not factorable. So you're going to use the quadratic formula. You guys want me to write down the formula for you? You have it. Or are we feeling pretty confident? Okay, so I want you to plug in your values for A, B, and C to use the quadratic formula. And I want to see if we can simplify it all the way. Okay, so our A is 1, our B is -4, our C is 2. So 4 plus or minus. I like to do the 4 squared in my head, and then I write out the 4AC, just because I know that sometimes this is going to turn into a plus, and I don't want to miss that. So here I have 16 minus 8. So I'm going to have 4 plus or minus √8 over 2. Remember, if there's a perfect square under the radical, we have to simplify that. Okay, so the perfect square in 8 is 4, so this will be 2√2. And then you need to divide each of these by 2 and simplify if you can simplify. If you have a whole number, that will simplify here, so that will be 2. And then you are only going to divide this by what's on the outside. Don't divide what's under the root. Okay, you're not going to simplify what's under the root because this is what's outside. So this is going to give you those 2 irrational zeros. Your final answer is going to be all of your zeros together. So remember, here you had -1 with a multiplicity of 2. And you can abbreviate multiplicity. You can say -1 with a mult of 2, and then 2 was a 0. And then remember, this plus and minus, those are 2 zeros. You can write them together. I just want you to understand how this adds up to 5. So -1 happens twice, that's 2. This is a plus and a minus, that's 4, and then 2 is the 5th one. Okay, so you do have 5 of those all together. Okay, so anytime you have something that's irrational, you're going to have to show your synthetic division and your quadratic formula. Okay, if they are rational and you can see them all from the graph, then you do not have to write that down, okay?